This is a 25-minute presentation for engineers. Gamalux Lighting Systems is a family-owned manufacturer in the business of linear lighting systems with headquarters in San Dimas, California. Our most popular product line is the G-Beam or Gamalux Beam series of fixtures, and this is that group of square and rectangular forms that have been so popular in the business for the last 10 or 15 years, in either suspended or surface-mounted, wall-mounted, and recessed. Now, what makes our product so popular is not its shape or its size, because there's so much similarity between different manufacturers across the industry. What makes our product so popular is its ability to adapt to complex applications, and this is where we try to set ourselves apart as a manufacturer. Now, in this particular application, you notice that we've got fixtures coming up the wall and across the ceiling, which is very common in the business these days. But what's uncommon is the condition of the ceiling and the wall. You notice actually there's a 3-inch gap between the wall and the ceiling. And this, of course, is very unusual. Well, we didn't make this choice. This was the architect's idea. They wanted to convey the concept of the ceiling floating up and down on rails of light at Schindler Elevator Corporation headquarters remodel. So because there's a gap between the fixture, between the walls and the ceiling, it creates a unique problem, and that is that the side of the fixture that's in the ceiling will actually be exposed. Well, we wouldn't want to use a recessed fixture in this recessed application because recessed fixtures are not very attractive on the sides. They have grooves and brackets and holes and places to add mounting components to interface with the ceiling. So rather than wanting to use a recessed fixture, what we actually did is we took a suspended fixture with smooth sides on it, and we modified it just in the areas where it was supposed to be integrated with the walls or with the ceiling, but we did not modify that housing in just the area where it's going to be exposed in that little 3-inch gap. And by doing that, we maintain a very clean aesthetic in the space while still providing the overall aesthetic advantage that the designer had envisioned. Now, when we build these patterns of fixtures, these recessed patterns of fixtures, we don't leave anything to chance. The way that we build them is very specific. We actually, for the fixture that's in the wall here, we actually allow it to come across the ceiling by about 6 inches. So we make an L-shaped fixture. And by doing that, we give the installing contractor a simple butt joint about 6 inches away from the corner condition, and that allows them to work with the most simple form of joining possible. So that at the end of this job, we were able to give the installing contractor a very simple form while still maintaining the original design intent. And so we're very much into collaborating on projects like this to understand what's special about that job so that we can modify our fixtures as necessary in order to meet the needs of the space. And we do those modifications usually at no additional cost. Now, in a very complex pattern of fixtures, whether it's suspended or recessed, you can see in the reflection in the glass here, this is quite a large pattern. This is one pattern of fixtures weaving its way through the entire floor of this building. Now, if you think about a very complex, large pattern of fixtures, you can imagine that there's a very large bill of materials associated with it as well, all the different parts and pieces that have to be ordered. And that's really where things start to go haywire, because every distributor and contractor that's bidding on the job, they all have a different interpretation of all the parts and pieces that are necessary to go into that pattern. And so when they send a quote request over to the sales office, those quote requests are not consistent with each other, so the sales office has to give different answers to each of those different distributors. And this, of course, creates inconsistency and a lot of confusion. So what we do is we want to offer to the designer, before the job goes to bid, we want to offer what we call a development drawing. It's the same drawing that we would provide after a purchase order, but we actually offer it before the job goes to bid. That development drawing takes all of the complexity of the designed pattern and actually creates a fully engineered drawing with mounting locations where we expect they're supposed to be, and the power feed locations, all the dimensions, all the angles. It's all laid out in one comprehensive drawing, and that entire pattern has one part number associated with it. This makes things very simple for those who are bidding the job, because now they're all asking the same questions to the sales office, and they will all get the same answer. We can also provide a price, a quotable price for this pattern of fixtures to the sales office, and then of course they will add the distributor and contractor markup locally. We at Gamalux, we never really know what those are. but the local sales offices do. And by doing this, we can provide, or our sales office can provide to the specifier a reasonable purchase price for this entire pattern of fixtures. And by doing that, now you you eliminate a lot of the question marks and the uncertainty associated with these complex jobs. Now, certainly when we receive the purchase order, there might be some changes. Some of the dimensions will change, mounting locations, power feeds, and such, maybe even the size of the fixture. But by starting with the designer's original design intent, we are allowed and we give other people the ability to maintain that original design intent throughout the entire process of purchasing, ordering, and assembling these fixtures. Now, because these big patterns of fixtures all have one part number, it's on us, Gamalux, to identify each component in those comprehensive patterns of fixtures. So we give each component what we call a mod number. And that mod number follows that component throughout the entire production procedure. Now, everything that we build at Gamalux is actually fully assembled twice before we pack it and ship it, whether it's a complex pattern like this or a 40-foot run using multiple housings. We fully assemble as a comprehensive pattern so that we can check, of course, all the dimensions, all the angles, making sure that the mounting locations are in the right positions, that the joining mechanisms all work and everything lines up properly. Then we take apart the entire pattern, paint it, put in the electrical, and reassemble the entire thing. Now we're checking every circuit, every battery pack. We're checking the dimming. We're checking the daylight harvesting sensors, the occupancy sensors. We're checking all aspects of these patterns of fixtures to ensure that they don't just look good but also perform properly. And we do this on every single job. So this is why our lead time is a little bit longer than our competitors, but what this does is ensures that everything looks and works the way that it should before the job, before the project ships out. And this is the way that engineers operate, by properly checking all the contingencies, by sometimes double checking to make sure that that their original findings are valid. See, Gamalux was founded 31 years ago by a father and son team of design engineers, and they owned and they run the company. And so it's important for us as a manufacturer to have that engineering mentality, which also means fine attention to detail. So we want you to understand that we think in engineering terms. Now, if you wanted to embed fixtures into the walls, usually you don't want to see that flange, that visible flange that goes around all four sides of that pattern of fixtures in the walls or in the ceiling. So you specify what you call a flangeless fixture. Well, those flangeless fixtures do have a flange, but it's a mud flange. It gets painted over and mudded and painted over, so you can't see it. Well, we have a mud flange on our fixture as well, but we actually include what we call an expansion gap as part of the construction of our fixture between our housing and the mud flange. The reason for this is because when the LEDs or fluorescent lamps come on in the fixture, they actually create a little bit of heat, and this heats up the housing. And you know what happens to any material that heats up? It expands. So as the housing expands and contracts, normally it would put pressure on the surrounding plaster because the mud flange is usually attached directly to the side of the fixture. And when it puts pressure on that surrounding plaster, eventually you start to see those cracks develop. But with our expansion gap built in at the factory as part of the construction of our fixture, it allows the housing to expand or even the walls to expand, and the two of those components never put pressure on each other. This eliminates the possibility of cracks developing over time. Now, if we wanted to build fixtures all into the architecture, maybe coming around all four sides of that built environment, obviously we have to have exact field dimensions for this kind of thing. We will quote to CAD or designed dimensions, but we never build to design dimensions because we know the walls will not be built to design dimensions. So we require field dimensions from the installing contractor before we will start going into production on any of these fixtures. Here's a pattern of what was a standard, suspended, 4-inch wide, 4-inch tall, direct illumination fixture, cable-mounted fixture. And all we did was modified it at the factory with miter joints that are welded into position as L-shaped fixtures or V-shaped fixtures or T-shaped fixtures at the factory so that the installing contractor isn't trying to put together all of these complex miters and instead is just working with simple butt joints away from those miters. Now, this particular application was for a medical facility named AVA in Seattle, where they wanted this installed on the walls in their parking garage to point people in the direction of where they need to go. Now, because this is a parking garage, maybe it's maybe there might be vandals or vagrants nearby. So, using the parking garage. So we also offer polycarbonate lenses in our fixtures for vandal resistance, and also tamper-resistant fasteners to hold those lenses in. All of our fixtures can be built either for individual or continuous run or patterns. Now, in those continuous runs, of course, we'll always fully illuminate that pattern from end to end with no dark spots and shadows. To my knowledge, we're the only manufacturer left who can make a 24-foot single-piece housing. See, we're working with extruded aluminum, which is very rigid. And if we have a tall rectangular shape, then that housing has a lot of strength to it. We can actually support that entire 24-foot single-piece housing with just 2 cables. Now, certainly, if it's a continuous run, there will be multiple housings in those continuous runs. But it's a great advantage to Gamalux to be able to make a 24-foot single-piece housing because it eliminates the possibility of light leak at joints between fixtures, sagging joints which don't line up properly, and possibly pinching wires between those housings as they're being joined together. Of course, how do you ship it? On a custom-made 25-foot pallet with a steel gondola holding the whole thing together, so when the forks come into the middle, we don't have 12 feet of fixtures dangling off the ends. We're very thorough in our methods. It's not about just building a quality product, but making sure that how we ship it maintains the quality of that product as well. Now, this is a detail that I don't normally show to most folks, but certainly for engineers, it's a very important and an appealing detail. This is the end of a fixture that's going to be joined to another fixture in a continuous run. Okay, so this will be half of a joint between 2 fixtures. Now, in order to create that joint, we add this joiner plate into the end of that housing, and of course we screw that onto the housing itself. Now, when it gets out to the job site, the installing contractor is going to use these 4 holes right here with a nut and a bolt in those 4 holes and the 4 holes in the adjacent fixture to join everything nice and tight. Now, when these screws tighten down onto that plate, they actually create a very undesirable effect, and that is they you know how screws go on, right? Righty-tighty, lefty-loosey, yeah? Well, when you tighten each of those screws down and you give it that last little moment of twist, you actually impart a very subtle twisting force into the housing, a torque. Now, it doesn't deform the housing or bend the housing, but it gives it a little bit of a desire to twist. Well, when you have that in every one of these joiner plates, and you've got 2 joiner plates at each joint, and you have multiple joints in a continuous run, then eventually something's got to give. And what ends up happening is in very long runs of fixtures, you may be able to detect a very subtle twist in those housings. And of course, this is a problem. So what we do at Gamalux, because we're owned and run by engineers, we actually use left turn and right turn screws to add these joiner plates into the end of our housing. Now, what this does is it equalizes and negates that twisting force, allowing for each of our joints to be perfectly straight all the way down our continuous run. So again, dealing with things with an engineering mentality solves a lot of problems before they even come up. Now, here's a designer's original concept of a 12-foot fixture where 8 feet of that fixture is embedded into the lower ceiling, and the whole 12-foot fixture has direct illumination to illuminate the floor below. But the last 4 feet of that 12-foot housing would be suspended or exposed out of the wall to provide indirect illumination to illuminate the upper ceiling above. And then just for kicks, the designer also wanted no cable support from above for that cantilevered portion. So rather than building a custom fixture and charging custom dollars, what we did is we took a standard suspended fixture, again with smooth sides on it, and we modified that 12-foot long suspended fixture with our mud flange and a mounting plate in that 8-foot section. And of course, we coordinate that mounting plate with the installing contractor before we start building the fixtures so that when they open up the boxes, they know exactly what they're going to be getting. In the last 4 feet of that fixture, we left the fixture unchanged. Lamp up, lamp down. This is a fluorescent job we did like 10 years ago, but the concepts still remain, even with LED. Now, rather than building a custom fixture, we just simply modified a standard fixture so that we could take that standard product and have 8 feet of that 12-foot housing embedded into the ceiling with the last 4 feet of that very same housing cantilevered out of the wall, and because of the rigidity of that housing material, we don't need the cable support from above. This is not a custom fixture. This went to the job site at less than $200 per linear foot, and we never got one phone call from the installing contractor afterwards. There was a lot of conference calls leading up to that and coordination with the mounting components, but once we get past that point and we go into production, the installing contractor knows exactly what they're going to be getting, and there are no problems in the field afterwards. Here's a pattern of fixtures in a ceiling. There's a wall right here in a ceiling directly above the camera. In a ceiling, separating two different types of ceilings. We have our mud flange around the outside of that pattern of fixtures, and then we have our grid flange on the inside of that pattern of fixtures. And in this particular case, the designer wanted the grid raised up 2 inches above the bottom of our fixture where the lens is snapped into. So we can actually use our fixture to delineate two different ceiling systems and also allow one of those ceiling systems to be at a different height than the other one. And we're doing all of this by using the fixture as the delineating element, which reduces a lot of the construction cost in the project and speeds up installation. Here's an application where we have an 18-foot single-piece housing, all one piece, going from fully recessed with flanges down low to carry the cut tiles, and then we go semi-recessed, 4 inches above, with flanges up high to carry the cut tiles. Now, again, do you see no grooves here, right? So this is actually a suspended fixture that we modified so that it could be recessed. Now, this trim detail actually butts across our fixture and every fixture all the way down the run. But because that trim detail actually cuts across our fixtures at an angle, it means that each of our flanges on the bottom and the top of our fixture had to be cut at different dimensions with a 3-degree angle in each of those cuts. And because this is happening at an angle, it occurs at a different location in every single fixture all the way down this side of the room, all the way down the left side of the room on 6 floors. This is all one type on the fixture schedule, but no two fixtures were identical. We cut those flanges down to 256 of an inch here at the factory to ensure that everything fits together like puzzle pieces. We never got one phone call from that installing contractor after the fixture shipped. And it's because of all the coordination that we do ahead of time. We're very much into the fine details and making sure that we get accurate information so we can build products appropriately for the space. This is the Hunter Douglas textile ceiling where the panels snap onto the grid from below, and the panels are 1 1/8 inches thick. What we did is we dropped our fixture 1 1/8 inches below the bottom of the grid. Now, because the panels snap onto the grid and they actually underlap the grid, so there's a piece of grid right here, but you can't see it because there's only a 1/4 inch gap between the panels that underlap the grid. We made our fixture a little bit wider on the bottom than it is on the top. So when it's snapped into the grid from below and butts up against the bottom of the grid, we maintain that 1/4 inch gap all the way around the fixtures, just like the panels have. So it's about consistency in the ceiling line and making sure that everything fits together the way that it should. This is the Hunter Douglas Box Series ceiling system. It's a metal ceiling system with a universal strut kind of deal directly above those panels, and the panels snap onto that unistrut, or that what they call a universal carrier. We made our fixture exactly the same width as the panels. And then we have a joiner spline in line with our fixture to join with the cut panel in line with our fixture. We use the same brackets on the top of the fixture that the panels use, so the installing contractor doesn't have to learn anything new. And we do all of this for total consistency in that ceiling line. The truth is, any fixture can fit into any ceiling system if you bang it into place and if you cut that ceiling in a way that it's not supposed to be cut. But we don't want people to have to do that. That's why we build our fixtures specific to that particular ceiling system, whether it's Armstrong or Hunter Douglas, you name it. Our brackets are always going to be designed properly to slide across to any position across our fixtures to interface with those universal carriers wherever they happen to occur. Now, when you're writing lighting calculations, obviously accuracy is very important. It's certainly a very important part of good design. So, in order to be accurate, in our lumens per foot delivered chart on page 2 of our specification sheet, we actually show you the actual lumens that are going to be delivered by those fixtures from real laboratory test results in all 5 color temperatures of the LEDs that we offer, in either standard output or high output, with either the medium diffuse lens or the heavy diffuse lens in the bottom of the fixture. Now, to my knowledge, we are the only manufacturer that actually shows you what the lens is going to look like in that fixture with the LEDs fully illuminated behind it. This is not a photoshopped image. We don't do that kind of thing. Now, certainly, every manufacturer has that glamour shot of the photos, of the fixture, in a very perfect condition. But nobody ever shows you what those lenses are going to look like as you're looking straight up from your desk up into the bottom of that fixture. We do. In addition to that image, right next to that image in our specification sheet, there's the hot link for your IES file. There's the hot link for your Revit file. So you don't have to go back to the manufacturer's zip file and play catalog number bingo trying to figure out which one is the right file. We always put that information out available for you in a very easy fashion. All of our fixtures can be made suitable for damp location. We don't do any wet location, but if the fixtures are under a canopy, even though it's an outdoor environment, we can build our fixtures for damp location to allow them to be suitable for that situation. Wall washing is a very important part of good lighting design. Obviously, if you're going to wash a wall, it's because there's something important happening on that wall, and usually you want to wash that wall as evenly as possible. With our wall wash fixture set 36 inches away from the wall, in this particular application, using 80-50-20 assumptions, we can get a max of 49-foot candles and a min of 42-foot candles. That is a 1 to 1.17 uniformity ratio on that wall, which is absolutely amazing. So uniformity on the wall is very important to us. So important that we actually add a kick reflector on the bottom of our fixture so that it can reflect light all the way to the top of the wall. Usually these wall wash fixtures have a shadow at the top of the wall. We don't want that, not on an object wall. So that's why our fixture has a kick reflector on the bottom. Also, the kick reflector acts as a glare shield, so the people in the room can't see up inside the fixture unless they're actually directly underneath it. These fixtures can be built to any length, whether they're individuals or continuous runs, and we can actually build them as comprehensive patterns, fully illuminated patterns as well. In the world of perimeter lighting systems, we've gotten rid of that ugly gap that's often found between the fixtures and the wall with our competitor fixtures. What we've done is we've created a mud flange that gets installed onto the unfinished wall just above the ceiling line. And that mud flange has a little groove which receives the reflector assembly from our fixture so that once it's installed, it eliminates the gap between the reflector and the finished wall, allowing the reflector to actually dive into the finished surface of the wall. As far as illumination, we can graze the wall to create shadows on the most shallow texture, or we can use the wall as a reflective surface with our ambient illumination optic to bounce light back out into the space. The grazing illumination uses a parabolic-shaped semi-specular aluminum reflector and a reflective lamp barrier. So light hits this lamp barrier, bounces up into the main reflector, so it can be shot straight down the wall to create this very nice, tight candle power curve. That fixture is almost 65% efficient, and the lamps are completely hidden from view, even in the reflection of a mirror. You actually can't see those lamps at all. Now, if you don't want to use the grazing optic and instead you want to use the ambient illumination optic to bounce light back out into the space, we have that as well. Rather than a semi-specular aluminum reflector, we use a white reflector, which is diffuse and allows more light to hit the top of the wall. Also, we eliminate that lamp barrier, allowing a direct spike of light onto the top of the wall that you see here. Those lamps are completely hidden from view when you look up into the fixture, and that fixture is over 79% efficient. These can be built in continuous runs or complex patterns. We've reintroduced the round fixture back into the world of lighting. It was gone for about 10 or 15 years. Of course, we've given our fixture rotation capabilities so that you can aim it wherever you like in the field. Our G-beam portal fixture takes advantage of all the integration capabilities of our G-beam housings, but rather than having a white lens on the fixture, we have this backlit acrylic. Now, we were not the first to go to market with this product. The Mark Finn was the first, but it has some exposed fasteners and fastener shadows and things of that nature, which we don't think are very pretty. So we've cleaned up the aesthetic for our version. If you're not going to be first to the market, you have to do a little bit better than the original. Our fixtures can be used as individuals or as continuous runs, where there will be a small gap between the acrylic blocks. In grid, gyp, fabric, metal ceilings, wood ceilings, doesn't really matter. All of our LED fixtures offer RGB function on DMX control, which is very common. If you need a white circuit, we will also include that as a completely independent circuit, so that it's capable of full output and complete dimming capability. All of our fixtures offer 13 standard finishes, as well as wood grain finishes as well for an adder, for a very unique kind of look, a distinctive type of look in the space. Obviously, that's not right for every job, but for the right jobs, it's quite a dynamic feature. We hope that you see that all of our attention to detail, the way that we manufacture, the way that we ship, and the way that we assist the installing contractor to do their very best work allows Gamalux to become part of the architecture in a dynamic and valuable way. Thank you very much.